iFour Technolab Private Limited, an ISO 9001-2015 certified and leading sustainable IT service provider. Presents tutorial of smart contract using Solidity. The purpose of this course is to give you complete understanding and hands of experience with smart contracting using Solidity for blockchain technology. In Chapter 1, Blockchain Essentials, covers an overview of blockchain technology and demystifies various blockchain jargons. We are going to discuss following topics: traditional system and challenges. What is blockchain? System architecture. Centralized, distributed and decentralized systems. Blockchain types, permissionless and permissioned. Mining, consensus, and incentive. Blockchain transactions. Anecdom and challenges. Security. Traditional databases use the architecture of the client-server network. A user can change information that is stored on a centralized server. Database control remains with a specified authority that authenticates the qualifications of a client before accessing the databases provided. Since this authority is responsible for the administration of the database, if the security of the authority is compromised, the data can be altered, or even deleted. We all understand that when it comes to morality and respect for the law, banks are not the most credible institutions. A lot of cash is spinning, and most banks have confidence issues. No history of records. In the case of a centralized database or traditional database, we have the information which is up to date at a particular moment. You can say that it is a snapshot of the current status. Transparency. The centralized traditional database does not support any type of transparency. Users cannot verify the information if they want to. However, an administrator may create a set of information public, but it is still impossible for an individual to perform the data verification. Chance of failure. These failures are due to the malfunctioning of the hardware, or a bug in the database software, or the operating system itself. It causes the loss of volatile storage content, and puts a halt to transaction processing. With this form of failure, the content of non-volatile storage does not affect. It is known as the fail-stop assumption. That the assumption that hardware errors and bugs stop the system, but do not corrupt the non-volatile storage content. What blockchain? Blockchain is a decentralized system. It means blockchain technology uses decentralized unity to preserve the network, which suggests that it is not centrally managed by the bank, the corporation, or the government. In fact, the larger the network grows, and becomes increasingly decentralized, the more secure it becomes. Blockchain technology refers to a transparent, trustless, publicly accessible registry that allows us to securely transfer ownership of value units using public key encryption and proof of working methods. Blockchain uses public key encryption and proof of working methods. Blockchain technology is not limited to Bitcoin. Bitcoin network is the first successful implementation of blockchain technology. It has gained a lot of attention in many industries, including financial services, charities, non-profits, arts, and e-commerce. Peer-to-peer network. Instead of keeping information in one central point, as is done by standard recording methods, multiple copies of the same data are stored in different locations, and on different devices on the network, such as computers or printers. This system is known as a peer-to-peer network. In peer-to-peer network, if one point of storage is damaged or lost, multiple copies remain safe and secure. Similarly, if one piece of information is changed without the agreement of the legal owners, there are numerous other examples in existence, where the information is true, making the false record out of date. Block in a blockchain is a collection of data. Data is added into the block through connected with other blocks, making a chain of blocks linked together. The first block in the blockchain is called Genesis block. Blockchain is a distributed registry, which means that a registry is spread over the network. Let's take an example of a Google spreadsheet or MS Excel. This spreadsheet is shared between different networks of computers, where everyone has a copy of it. The spreadsheet contains information about the transactions committed by people. Everyone can access that spreadsheet, but no one can edit it. The information recorded on a blockchain can take on any form, whether it be denoting a transfer of money, ownership, a transaction, someone's identity, an agreement between two parties, or even how much electricity a light bulb has used. However, to do so requires confirmation from various devices, such as computers, on the network. Once an agreement, otherwise known as a unity, is reached between these devices to store something on a blockchain, it is unquestionably there, it cannot be disputed, removed, altered, exchanged without the knowledge and permission of those who made that record, as well as the wider community. Chain. Some attributes of blockchain are proved that blockchain is better than the traditional system. Peer-to-peer. No intermediate authority to control or manipulate it. All participant talks to each other directly. This allows for data exchange to be made directly with third parties' involvement. Distributed. The registry is spread across the whole network, which makes tampering not so easy. Cryptographically secured. Cryptography is used for the security services to make the registry tamper-proof. Add-only. Data can only be added in the blockchain with time sequential order. This property suggests that once data is added to the blockchain, it is almost not possible to change that data and can be considered practically fixed. Consensus. Unity is the most critical attribute of all. This gives blockchain the facility to update the registry via unity. This is what gives it the power of decentralization. No central authority is in control of updating the registry. Instead, any update made to the blockchain is authorized against strict criteria defined by the blockchain protocol, and added to the blockchain, only after it has been extended among all participating peers or nodes on the network. Architecture. The architecture of blockchain. Centralized system. In a centralized system, one entity, like a person or an enterprise, controls the entire system. Decentralized system. In a decentralized system, there is no single controlling entity. Instead, control is shared among several independent entities. Distributed system. A distributed system contains multiple nodes that are physically separate, but linked together using the network. All the nodes in this system communicate with each other, and handle processes in tandem. Each of these nodes contains a small part of the distributed operating system software. Blockchain types: permissionless and permissioned. Blockchain has three types of network: public network, private network, permissioned network. The blockchain has considerably showcased its extensiveness in laying solutions to the essential market issues like security, transparency, accountability, time consumption, value and more. Every custom blockchain development company has witnessed the big play of blockchain in improving the efficiency and effectiveness of the industry function. A blockchain is maintained on a decentralized and distributed network of computers. There are few flavors of blockchain that have emerged in recent years. Public. What is public network? As the name suggests, the public network is open to all. It can be joined by anyone with all the access rights to read, write and validate the blocks. Each entity participating in the network is known as a node. In public networks, the identity of nodes is not known, and there can be several advantages of it. Why to choose public network? Equality. All the users will be treated equally as nobody is aware of who is another one in the network. The job of all the nodes present in the network is to read, write, and validate blocks, in case they are interested, without knowing about the other node's identity. Removal of a central authority, which is one of the biggest motives of blockchain. All the transactions are open and transparent. Every node in the network can monitor the transactions, and if a transaction fails to receive consensus, then it is not added to the block, thus making the chain more secure. Why not to choose public network? Each block will be of limited size. Transaction cost is high as miners will take the mining fee. The process of adding a block to the chain will take days, or even weeks if the mining fee provided is less. There will be several miners mine the same block if proof of work is followed, wasting multiple resources and energy. Transactions added are public, so if someone knows your public key, then all the transactions made by you will be known. As for the size of blockchain increases, scalability decreases. Network. What is a private network? A central authority decides who can read, write, or verify transactions. This kind of architecture is followed by an organization to keep data limited to the authority. Public read access may be allowed. Why to choose private network? Users will have an identity known to each other, so every node in the network will be able to see the details of the transaction initiator, preventing the frauds. Users can join only through authentic and verified invitation. Transactions can only be approved by the nodes having the authority. Not decentralized but is distributed and is secured based on cryptography concepts. No transaction cost. Quick action on approval or disapproval of transactions. Data will only be shared with trusted nodes, improving the privacy and security of the data. Why not to choose private network? Not decentralized and thus avoids one of the most important features of blockchain. Example: Hyperledger, Hashgraph, R3 Corda, etc. Real-life example: a person dealing with various suppliers must want to hide the contracts signed with another supplier. The financial details from the customers must also be kept hidden, thus different rights to different users can be provided in the private network. Permissioned network. There is a thin line gap in private and permissioned network. The private network has a single organization as a central authority, while permissioned network has multiple organizations as a central authority. Multiple organizations involving in this process must have trust in each other to read, write, and validate transactions. Example: Bitcoin is the best known example of a public network. Other cryptocurrencies following public networks are Ethereum, Litecoin, etc. This kind of architecture is not good for enterprises, as they want only limited people present in their organization to access the data they share by their roles. The private network can be followed to achieve this aspect. Public, private and permissioned blockchain. Anyone can access public blockchain, but only by invite can access private and permissioned blockchain. Public blockchain is a decentralized network type, while private and permissioned blockchain is partial. The consensus in public blockchain is done by the mining process, and in private and permissioned blockchain it is done by the method agreed between participants. Anyone can read, write, and verify blocks in public blockchain, while the only owner of private blockchain can read, write, verify rights. Permissioned blockchain is controlled by predefined nodes. Mining. Blockchain mining relates to the activity carried out on the network by miners to add the fresh blocks to the blockchain. In other words, mining is the system that allows the blockchain to be created securely and decentrally. It offers the basis for the cryptocurrency system, and allows a peer-to-peer network without a central authority. Miners validate and record new transactions on the blockchain. On average, every 10 minutes a block is mined. In the form of transaction fees, miners can also obtain benefits on the transactions of the block. The winning miner can keep the change if the miner finds a hash that matches the current target. Ether will be awarded to the miner for each node to validate and add the ledger to their copy, and broadcast the block across the network. If miner B finds a hash, miner A will stop working on the current block. Miner A will stop working on the current block and repeat the process for the next block. The consensus is a protocol. Consensus rules are a specific set of rules when validating that block and the transactions within it. Nodes on the network will ensure a block follows. There are two types of consensus in the blockchain network. 1. Proof of work. Proof of work is a consensus algorithm that decides which node writes the new block from the given network. Proof of work is followed by Bitcoin and Ethereum, both with minor variation. With proof of work, each miner or node competes with each other and gets rewarded at the end. Each mathematical puzzle or function to solve is provided to each node, miner. 2. Proof stack. Ethereum plans to move from proof of work to proof of stack shortly. Stakeholder proof will virtualize the entire mining process and replace miners with validators. This is how the process will work. Some of their coins will have to be locked up as stack by the validators. After that, they will start validating the blocks. In other words, they will validate it by putting a bet on it when they find a block that they believe can be added to the chain. If the block gets appended, then the validators will get a reward proportionate to their bets. An incentive is any design element of a system that influences system participants' behavior by changing the relative costs and benefits of choices that may be made by those participants. Incentives include pay-for-performance reward schemes that make up for cash for people and include systems that do not integrate any monetary benefits at all. Encourage communities of participants to cooperate and create the value that will ensure the success of their platform. University course grades, for example, provide powerful incentives for students to study hard, all without the university or the course instructor giving the student a dime. Companies, platforms, and governments all operate systems in which each individual participant makes choices that best suit for them. These choices involve trade-offs, which balance costs and benefits. Costs and benefits can be immediate and monetary, but they can also be long-run and/or non-financial. When those costs and benefits from a system that has been chosen by an entity like a university or a blockchain startup, they are incentives. Blockchain transactions. Transaction flow on a blockchain. All the time there are transactions taking place between different nodes on the network. Until validated in a block, these transactions will not be recognized. Special nodes, called miners, pick up several transactions. They first validate all the transactions to see that all the transactions are fair and valid and do not contain any fraudulent transactions with problems such as double spending, etc. Upon validation of the transactions, the miners generate a block of the transactions he chose. This block contains a sequential ID, the miner's selected transactions, SHA-256 hash of all values, and the previous block's hash. The blockchain consensus needs miners to fix a computational intensive difficult mathematical issue, to sign the block produced before it is broadcast to the network. The other miners validate the issue solution, and accept the block if validated, and start the race for the next block. That's it in this video. Thank you for watching and stay tuned for our next video.